Okay. So hey guys, welcome to our developer hour session. Is my screen visible? Hi, can anybody just confirm if my screen is visible?
Yeah, it is visible.
Yes.
Okay, thank you, Shubham. All right. Hello everyone and welcome to today's developer hour on Shutter integration. I am Parul, developer relations at Claros, and I am excited to host today's technical deep dive. For those who are new to our developer office hours, this is a bi-weekly series where we deep dive into different integrations and tools in the Claros ecosystem. Let me quickly recap our journey so far. In our first session, we introduced the developer office hour concept and covered a comprehensive overview of Claros development tools. We explored the V2 architecture with its cross-chain capabilities. In our second session, we focused on integration strategies, where we deep dived into two main routes for integrating Claros: the Trustless direct smart contract integration for Web3 native teams, and the recognition of jurisdiction approach via dispute resolver. In our third session, we have Madhur from Proof of Humanity demonstrated the groundbreaking integration between POH and Circles. In our last session, Guangmian showed us something different yet equally important: Lockler, a solution that requires no integration at all. Today, we are diving deep into one of the most significant technical achievements we mentioned in our first session, the Shutter network integration. We have special guest with us today, JB, our development lead at Claros. Let me outline what we'll cover and then I'll hand it over to JB for the technical deep dive. We will start by examining the problem statement. Why a traditional commit reveal process needed improvement? Many of you have probably experienced the friction of two-step voting process, so this will resonate. Then we will explore the Shutter integration architecture, how their decentralized Keyper network and threshold encryption works under the hood. We'll walk through the user experience transformation. This is where you will see improvement from a manual two-step process to what we are calling automated reveal. The technical implementation section will be our deep dive. JB will show you the flow and how everything works together. We'll cover the security and privacy guarantees that make the system trustless and robust. We'll share our current status, what we have achieved on DevNet, and where are we in development. We'll highlight the key technical implementation components and integration details that make the system successful. And finally, we will have time for Q&A. I encourage you to ask questions throughout or save them for the end. Before we deep dive into the technical details, let me introduce our guest speaker, JB. He is our development lead at Claros, where he oversees the technical architecture and implementation of dispute resolution protocols. JB, over to you.
I guess. All right. Okay, so I can start by giving you a brief overview. Okay, do you want to move to the next slide, Paul, please?
Sure.
Okay, so if you are familiar with the Claros Core V1, in most cases currently we are just going through different periods. When a case is created, if you're drawn as a juror, there's first an evidence period. and then there's a voting period. In most cases, nowadays, we have not implemented any commit reveal, any hidden votes. So the commit reveal is really a technical term. It's one way of implementing hidden votes. And hidden votes means that as a juror, at voting time, you don't know what other people have voted. And you will see what other people have voted later when the voting period is finished. And you will see, of course, which option is winning the dispute. More in voting systems, you don't really need to actually reveal what people have voted, but because we're on the blockchain, it would become probably it would become visible in some way probably. But okay, let's stay focused on this. So currently we don't typically enable any commit reveal, and I'm going to explain why. It has actually some benefits in terms of security. It really incentivizes the jurors to do their homework, not to be lazy, not to just follow the majority, and it makes it more difficult to coordinate any sort of manipulation of the votes. That's when you cannot see what other people have voted just before you. When you know what people have voted, you could wait for the last minute of the voting period and just follow the majority, and that would be a lazy voting strategy, which I don't recommend, by the way, because there might be an appeal and you might lose in the appeal round, but still it's suboptimal. So the better approach is to have hidden votes, and the typical implementation for this is a commit reveal, which is 2 steps. First, a commitment, which is a hash, so it doesn't leak any information, and that's one extra period in the resolution of the dispute. And then there's a second period, which is the reveal stage, where the juror comes back and reveal their vote. So this process has been implemented in Kleros v1, and ideally it would be the default behavior. Every dispute would be typically using this logic, but we realized that it comes with some trade-offs, mostly on the UX. It forces the jurors to come back to reveal their votes in a very specific period, which is usually 1 or 2 days. But it still happens unless someone is dedicated full time to being a Kleros juror. It's quite easy.
I think there was some glitch from JB's end.
Okay. Looks like I got disconnected.
Okay.
Yeah. So yeah, that's where Shutter comes in. Let's move to the next slide.
Sure.
All right. So as I was saying, Shutter provides a threshold encryption protocol. It's so you could imagine we could have implemented this without Shutter. We could just have a server somewhere that is encrypting things and issuing a decryption key, but that would be centralized. That would mean that the Kleros developers have access to the votes if they wanted to or if they were compromised, and we absolutely don't want this. So the Shutter network is a decentralized network of nodes which all have a share of a key, and they need a consensus to decrypt and publish the decryption key. So they have their own protocol to incentivize what they call the Keyper bots to behave, in particular, not to decrypt early, and also to decrypt correctly the correct information. All right. Yeah. So with the right implementation of with the right integration of the Shutter protocol, it's actually possible for neither any Kleros server, any Kleros developer, or anyone at Shutter to know what anyone has encrypted until the reveal period comes and the decryption key becomes available. At that point, when the decryption key becomes available, anyone is completely permissionless. So anyone can retrieve the decryption key and decrypt the votes. Even if Kleros was not here tomorrow, anyone could just do this. All right. After this, I was planning to do a demo. Okay, so we were just testing just before this, and there were some errors, and we're actually chatting with the Shutter team right now. I'll do this again. Let's see if it works. So I'll go through the entire flow.
Okay, I'll
Oh.
stop my screen.
Yeah, I just realized I need to share my screen. Okay, just give me a moment. Can you see it?
No.
No, you cannot see it. Okay, I think I need to fix the permissions. Okay, sorry guys. I need a minute of permissions, and I'll be right back.
Yeah, sure.
Is it better now?
It's not visible right now. It was earlier visible.
It was visible earlier.
Yeah. The quality was not so great, but it was visible.
Okay. Okay, trying again. Okay, can you see anything now?
No.
Anything? No, still not.
Uh, if it's not visible, then we can probably proceed with technical architecture and maybe later come back to the demo part. Oh, is one.
How is it now?
I cannot see your screen.
Like, it's not showing
Oh,
anything.
it's visible. Yeah, it's fine. It's working.
Okay, something is working.
Yes.
All right. So what you can see here is the code v2. We are going to create a case. I'll just reuse an existing case. I'll just speed run it. Well, the important part here is that the dispute creator would use the shorter dispute kit to use this new feature, which might become the default in the future. All right, I'm creating the case. I'm signing with my wallet. All right, the case is created. We just have to, okay, I'll just talk for the next 2 minutes, drawing some zeros for this case, and I should be drawn. Okay, I've been drawn. Okay, now we just wait for a minute and a half to see the in the Okay, we still have 28 seconds. What else can you say about this integration? There's the blog article written by Shutter about this integration with more details. We can share it later. And okay, 8 seconds. Right, we can move to the commit period. Oh, wait. To say to vote yet. Oh, ouais. Ouais. We are going to fix this is typically what we would tell the jurors if they need to manually reveal, and this won't actually be necessary here. So we'll come back in 2.5 minutes. And a second. Okay, so for the I had it just before. Okay, so we can share this link later. This is public. You can take a look at it. This so this way of integrating the Shutter network allows us to not depend on any trusted bot. There would be other ways of integrating the Shutter network, which would be permissioned. And yeah, we've been very careful of not adding any trust assumption. So okay, we can maybe expand a bit on this. So this is the juror, the Shutter protocol part and the voting contract. The first half is the voting session, and the second part is the reveal. So without going into too much details, we can say that we can get some encryption material to encrypt three things. We encrypt the choice, the justification that we provided in the front end, and the salt. The salt is generated in the front end, and we encrypt this. It's provided to the contract on chain, and later when the decryption key becomes available, we use it to decrypt. And the voting contract will verify that the decrypted, that's very important actually. We verify on chain that the decrypted values actually match the commitment. So we hash on chain the vote and the justification, all those parameters, and it has to match the commitment. All right, let's come back to the case. So it's moved to the voting period. There's an option here for the user. If the user actually wants it, it's possible to reveal the vote manually. Okay, let's see what the bot is doing. All right, so, okay, it says it's too early. Okay, maybe we need to wait a bit more. The bot is running. Well, yeah, I'm not exactly sure. Yeah. Yeah, the commitment is in. Okay, well, this is deployment, and we are not able to test the entire flow just before this for other reasons. So once we will fix those issues ASAP, and typically here you will have your vote automatically revealed in a single step, and yeah, you could just wait for the dispute to resolve as a juror. So yeah, do we want to get into more details? Yeah, I think we've covered this already.
Yes, we have covered this.
All right, so the current status it's live on Testnet. That's really an internal deployment. It's actually DevNet. The next steps will be to release it. We are looking at a release in the coming weeks. I don't want to influence any prediction market, so I'm not going to be too precise, but yeah, it should be out soon. Yeah, I think maybe I'll just add one thing. So Shutter has actually been this solution of using Shutter. It's been they have two main applications at the moment. One is hidden votes, and another big one is MEV production. Originally, the Shutter network was focusing on hidden votes, and they were working with Snapshot to provide the hidden votes functionality, which has been released and it's live. It's used in production by a number of projects. And only recently they've released the Kleros API solution, which we are now using. And the main difference for us when integrating Shutter for Kleros is that our voting protocol is on chain, and that meant we had a number of other challenges to keep it trustless. Whereas the previous integration for hidden votes with Snapshot, Snapshot is off chain. It's not Snapshot X, which is their latest product, and it's on-chain voting. But yeah, that was really a first. I think we are the first integration with Shutter for on-chain voting. So yeah, I'll leave it here. I don't know if there's any question by anyone.
No, there are no questions yet. But thank you so much, JB, for that comprehensive technical walkthrough. If
Thank you.
anybody has questions, please shoot them. And we'll share the resources for the Shutter network and our repositories. And if you have any more questions, you can contact us through our email. So if anybody has any questions, the floor is open. I guess not. So I'll wrap the session for today. Thank you all for joining Developer Hour.
Thank you, Paul.
Thank you.
See you, everyone. Bye.
Bye.